William Hadala. Thank you for joining in on this episode 2 of the Watt Hour. Today, I am joined by our guest, Marcus Rossi from Primordis. How are you?
I'm great, William. It's great to be with you today.
Excellent. So I was honored to meet Marcus through friends of ours at NAVSEA Crane by a gentleman, one of their scientists by the name of Tom Adams. And as you know, we're tackling the challenges related to battery storage and the warfighter and commercial markets across land, sea, air, and space. One of the challenges that we face is how do you have intelligence not only at the battery management system, but in order to make command and control decisions, especially when you are working across autonomous platforms that need to make intelligent decisions that commanders need to take into consideration that may mean the quality of life of people that those decisions are affecting. So, Marcus, thank you for joining us. And to kick things off, can you share a little bit about your journey from the Marine Corps to becoming a CEO of Primordis?
Yeah, thank you, William. So I was in the Marine Corps for about 24 years. Made my way from a junior officer. I was a combat engineer officer. So as a combat engineer, one of the unique things about that that job function in the Marine Corps is you work on all elements of the force. So you spend time with the infantry and the ground combat element, where you do like breaching operations. We did route clearance, clearing IEDs, a whole variety of things of that nature, kind of the mobility of your ground forces. Then you are in the logistics element where you're operating the bases, the logistics support, and the infrastructure required to sustain combat. And then I also worked in the air wing. So those where you're kind of running the ground support to the building the runways, it's maintaining them, the fuel for the aircraft, all those different pieces across the force. So across that career, I deployed 7 times. I saw all these things on the ground, lived them. And then as a senior officer, I became a strategic planner, which was pretty significant. I worked on our national war plans, our national defense planning scenarios, and spent a lot of time kind of looking at the trends, both from technology, the emerging technology that's changing the world, that's changing how you secure, how you defend a nation, how you secure a nation, and also that's how that affects human society and all the human impacts, human and political impacts of those changes, and accounting for all of those and what we need to invest in and what we need to do. So I was part of kind of the modernization effort across the DoD. I had a big role in the Marine Corps' Force Design 2030 effort, which is the largest kind of redesign of the Marine Corps since World War II, really to account for a lot of these things. When you talk about kind of the role that batteries and smart AI and robotics are playing around the world, we saw all that, we studied it, we modeled it, and we kind of accounted for it. And you can't predict everything, but you have to do your best as a nation to decide what you're going to invest in and how you're going to build up your defense force and your society to be prosperous in the era that we're in today.
Wow, thank you very much, first of all, for your service. And, what an amazing experience for you to go through. Oh, how did your experience as a lieutenant colonel shape your leadership style and approach to innovation?
Great question. So, again, as a leader, we had to, um, bounce back between, all the elements of your junior Marines coming into the force and how you have to train them and how you have to operate them. And, I had operated at a time, when we were kind of, our U.S. military was kind of, taken aback a little bit by the types of, in the IED fight, the counter IED fight, the types of technology that adversaries could come up with, without a lot of money, without a lot of resources, to really kind of throw off some of what we were building. And then as a lieutenant colonel, I started to see that, that what we had seen in Iraq and Afghanistan was just, the tip of the iceberg. Particularly when you see kind of the types of technologies that are coming out now. So again, my leadership style, I would say, was very much informed by um, the urgency of bringing out the talent of our young Marines and sailors that were coming into the force, but also as a different type of talent. You know, you still have to have the the tenacity and the ability to adapt and change and deal with toughness and deal with adversity and overcome, you know, obstacles. But we also need to bring in a lot more technically savvy kind of skill sets, right? You know, you have nowadays you have FPV drones, first person view drones, which is like flying a video game, right? You have cyber warriors, which have to understand how these systems are operated. And really, it's the transformation was this, you know, we see this increase of software defined hardware, and we haven't built that force yet. So I really try to bring out the talent in the people that I did have, but I also had to become an advocate for changing, you know, modernizing the force, modernizing our workforce, you know, modernizing our technology. We have to divest of some of these old technologies that are taking up a lot of our money and our bandwidth and invest in new things.
Yeah, tenacity. I talk about that all the time. Former CEO that I worked with, so that I can, there's four things. There's time, there's talent, and there's the training. But the one thing that I cannot give you is tenacity. But beyond that, being part of the force as we've been formulating these plans to now see them coming to market, um, you know, you know, what was really the spark that led to the founding and your focus with energy storage?
That's a great question, William, and it's also kind of why I think you and I are friends and are working together. So, you know, we saw the trends. There was two powerful trends that are really changing our society. You know, that's the widespread adoption of AI and the widespread adoption of autonomous systems. You know, in defense, we started to talk about you're going to have these autonomous systems from the seabeds to the Kármán line and across the battle space. These autonomous, you know, sensors systems from the bottom of the ocean all the way out to the edge of space and beyond. Your ground forces, as we've seen your crane at the front, they're very, very vulnerable to autonomous systems. I mean, the drone has become the dominant weapon of war. And that means that your command posts have to be smaller. They have to be dispersed. They have to be, agile. They have to be logistically supported. And in warfare, there's this saying that we would always talk about, which is that amateurs talk tactics and professionals talk logistics. And that kind of comes from, you know, thousands of years of study. There's been very few for wars where a brilliant combat maneuver has really changed the game. At the end of the game, it's can you sustain this force? Can you build a logistics infrastructure to support it? And so I got out of the DoD because felt the pace of our development wasn't fast enough. I wanted to help build these solutions, build these capabilities, build the type of things, you know, work with companies like, you know, ALE that are building better batteries, that are building more energy dense batteries, because that solves a lot. You know, we when we talk about fielding large number of autonomous systems, like I just talked, and field them in distributed fashion and enable a whole lot of the concepts that the defense forces are looking at. We need new technologies, better solutions, and we need to build the logistics infrastructure, the logistics architecture that is able to sustain that and is able to be agile and adapt to, you know, what the adversary, because the adversary is going to target our logistics first and foremost. They're going to go after our companies. They're going to go after the ability to keep forces in the fight. So when we talk about smart batteries, when we talk about energy dense batteries, better solutions that can operate in many different environments, that can operate in those autonomous systems that could be on the bottom of the ocean, they could be out in space, or they could be at a really remote site where you're facing, you know, you're in the rain, or you can't have the big command posts that I grew up with, right? You got to have these small agile forces. So what what I came across is I paired with some really talented co-founders, one of whom is a professor of aeronautics at Purdue, and the other is a semiconductor and AI designer in the Bay Area. And so between the three of us, really coming out of some work that Purdue had done with NAVSEA Crane over a decade long, you know, there's a core model of energy intelligence, and what we want to do is bring energy intelligence into all of these devices to really extend their range, extend their endurance, but become kind of that onboard energy brain that makes them able to predict forward how all the different subsystems on the devices will be used and manage it in such a way that you get more out of every, you know, you kind of can customize, you can customize the mission to get done what you need to get done. So that's what we're trying to do, is kind of transform, you know, become the core energy model across all these systems and make them more intelligent and makes them do more with the finite resources they have available.
Yeah, I like that, the onboard brain. So what I'm going to do here is I'm going to go ahead and share a slide that you shared with us. And when I do so, it would be interesting to understand, let's see here. There we go. Yeah, so AI energy endurance and what I love what you said is really being the online brain and intelligence is so important when it comes to battery management. So tell us about the AI battery management system that your team has developed and what makes it different from a traditional BMS.
Yeah, well, if you go to the next slide, it's kind of a nice visual that tells this story. So what we have, I mean, a lot of people understand like LLMs now because people are starting to use them. They're starting to use them regularly, and the LLM is trained on a very large data set, and then you build customized agents for specific business problems for specific tools. So what we have is a core model that has a whole lot of intelligence about energy, both the energy that's delivered from the batteries and how to um, moderate and manage that in such a way to get the most out of those batteries, but also the intelligence about how the different subsystems are going to use it, how different subsystems draws will be affected and how they'll combine, et cetera. So that combined intelligence is the core model. And so we don't build BMSs, we don't build a battery management system, but what our software does is make a battery management system intelligent. So it can sit right on top of the management system anywhere there's a BMS. And we've talked about this. It could be at the battery pack level, at the sub pack level, um, but it interacts with the operating system of the device so the operating system of the drone, the operating system of an edge storage device, edge energy device, atmospheric water generator, anything that is electrified, and eventually anything that is anything that's electric, and eventually anything that's electrified. So and kind of going back to that story of the changes in defense, you have all these systems across and not just the systems that are fully battery powered. Eventually, it's going to be you have smart batteries built into the architecture of everything from missiles to satellites to self-driving vehicles, to semi-autonomous. So it'll eventually serve both autonomous and semi-autonomous systems. But by able to understand how the energy understand that forward energy state based on all the different permutations of how the subsystems might use it, it can provide that predictability, that forward projection, which is what that's what kind of AI does, right? It provides that forward kind of learning and understanding and projection to allow the operator or the OEM that's building this device to get the most out of the system. So we think this
Yeah.
adds. We've demonstrated this adds 20. For a variety of drones that are out there today. This can increase their battery, their mission endurance or their range by 20% or more, and also make those batteries last 20 to 30% longer across their lifespan.
So it's safe to say that this sits above the BMS and this AI enablement optimizes the performance, it predicts degradation, it prevents like catastrophic failure in battery packs. Is that a fair assumption?
That's a great readback, William. That's exactly right.
Good. And then is this platform, it sounds like it is, that it's chemistry agnostic or tailored to specific cell types like LFP, LMFP, NMC, whatever it may be. So it's like, talk to me a little bit about that.
Yeah, so that's actually the very unique thing about the technology is that this core model has been trained to be chemistry agnostic. So it's been trained on over 200 data sets, many different battery chemistries, and it's able to do this prediction and this moderation of the battery, on different type of batteries. So again, if you are a drone, if you're an autonomous systems OEM and you're buying the best battery that ALE builds today, and that's your solution for your drone, and then William, your team comes up with a better battery in 12 months, and you've cracked the code, you have a more energy dense battery, you've got a better solution. The AI will still work with that new battery. In fact, it will just magnify the performance increase of your battery across everything else that autonomous system is doing.
That's fantastic. And, everything you've said can leave it to the imagination of use cases. When you're dealing with real-time decision making at the edge, is this like an AI system that's embedded or is it cloud augmented?
So yeah, it can be it can be both. So depending on the use case, depending on the customer application, right? It can be a cloud solution that is accessed via APIs, or can be a secure software enclave on the device. And eventually, we're going to build a customized ASIC chip to deliver this. You have to basically multiply the delivery options and make it even more energy efficient.
So, given your military background, how is Primordis bridging defense needs with commercial energy tech?
That's a great question. So I think, I talk a lot about defense, and I'm very passionate about, enabling the next generation. I want the next generation of young men and women who volunteer to serve our country and our allies and allies militaries to be well supported, well defended, and have the best technology. So I want our autonomous systems to be that 20 to 30% better than anything that the adversary gets. And your range and endurance is what gets that. But this same technology, when we started to look, I worked for Skydio for a while, America's largest small drone builder, and they have customers in utility companies across the country. They have logistics customers, state and local governments, police. Drone as first responder has become a big thing across police departments, and other areas where you use a lot of autonomous systems. We're seeing, agriculture is a big one where drones have become really dominant. A lot of logistics and shipping applications, research applications, and you see these self-driving cars and taxis. So we see all of those as customers of our technology. In fact, we'd like to be the core energy intelligence across all the electrified and electric devices around the world. And with that combined learning, just like your best LLM is going to learn from the more data sets, we anticipate we will become kind of that core energy language for controlling, for managing and controlling the energy applications in many different types of electric.
Oh, that's awesome. And being a battery cell manufacturer with American Lithium Energy, I always ask questions like, from your perspective, what do you see as the most urgent battery related challenges in modern military operations? Is it power density, safety, predictability?
All of the above. Certainly see, and I talked to the applications vary, but I certainly see kind of as we're, if you think of the things we're feeling, like the soldier-borne systems the Army's trying to buy, right? The VR helmets that Anduril and Meta are now, are in the business of making, right? That you're putting weight and gear on a soldier, and they, and that comes up with the logistics resupply mission, right? The drones obviously is a big one. We've seen, we just saw in Russia, $100,000 worth of very cheap drones take out $7 billion of high-end aircraft. It was the rough estimate from an attack about a week ago. All those small drones use batteries, whereas those big aircraft were using fuel. And some of our adversaries are building a lot of missiles and capabilities to disrupt our fuel sources. I think, certainly, the battery energy density is big because it gets a more powerful, longer lasting system out there. But safety remains extremely important. Endurance is obviously the problem that we're solving, and that makes everything better, right? It solves the entire system. That's why I'm passionate about it. I want to fix everything. I don't want to fix one drone. I want to make the whole system, work better, last longer, and do more. So that when we use, and this both in industry and in defense, when you put a human out there to go out and do the mission, in a utility company, you might be going out to the power line and inspecting it in person. If you need to do that, you need to do that. But if the machine can do that for you, and the human can do something that's better for you, that's more creative, the things we love, that's what and in the defense, same thing. We don't want to put a human in harm's way when we can use a machine to do some of the things I used to do as a combat engineer, the breaching operations, right? The surveillance, a lot of these things can be done from a distance or from a safe position, which is more and more important when your adversary has the ability to harm you in more ways than they used to, right? So I think it's a similar story, but those three things that you talked about, I would probably have to say are all equally important.
Yeah, and safety, here we are talking about autonomous systems, but obviously these can go into systems that humans operate or are using. But, safety even at the cell level, with safe core, the ability to prevent the three most common reasons why cells go into thermal runaway, which are internal shorts, overcharging and temperature, and even 0 volt, it's safely taking a cell down to 0 volt. At some point, those cells, regardless if a human is using it or not, because it's flying, it's in space, it's on land, it's on sea, it's gonna need to be transported. It's gonna need to go on a ship, on a truck, it's gonna go in a backpack, it's gonna go into a Pelican case or whatever it may be. So it's important from a service warranty, even support perspective, to understand the state of health of those batteries at any given time, and to have that data come back. It's no difference than doing fuel logistics, right? Getting diesel fuel into the field. My tanks are empty, they're full, I need to transport, I need to distribute. Well, safety is so key here.
That's huge. I've lived that, William. You asked me about my leadership style as a lieutenant colonel. I mean, as a lieutenant colonel, we were on the ship, with my entire squadron, and we were demonstrating some of these new TTPs and tactics that we wanted to use based on, and just convincing the captain of the ship to bring on certain capabilities. That those battery safety issues become a really really major thing when you're on a confined space with a lot of fuel, with a lot of high end equipment. You can't have a thermal runaway. You can't have some of these safety problems. So that's huge.
That's why I love that we're infusing your tech with what we're building at ALE to not only have intrinsically safe cells, but intrinsically safe battery packs, rather than, transporting vehicles with lithium ion batteries that they have to have at 20% state of charge because you'll destroy the copper anodes of those cells. So, these ships go on fire and they're not even bringing them on shore or even trying to extinguish the fires. From a DoD perspective, that cannot happen, and hopefully in time the powers to be will realize that shouldn't happen in the commercial sector. So, as we move on here, what does the next evolution of intelligent energy systems look like to you, especially in high risk or autonomous platforms?
I think the next generation of intelligence energy systems is the combination of um, the the chemical and technical solutions that companies like ALE are building with energy intelligence that not only is on the device, but is input into the mission planning software and the logistics software that sits over it. So you're predicting this stuff for individual devices, but at the system level, when organization, whether it's a military force or a utility company or a logistics company is using large numbers of these systems, you have early warning, early prediction, and you have mitigation tools that are built in, mitigation strategies that are built into your mission planning tools. So you're that's where we see our technology going. Is it supports the OEM that's building these autonomous systems, but eventually also supports these really powerful swarming, fleet management tools, and there's a whole variety of them. But they sit on top of this of these systems, and they can learn in real time, when and where to use different systems. So maybe you don't even lose, because you're forward predicting. You have it. You have indication that a certain system is becoming vulnerable, and you can replace it. You can get another drone or something without losing any coverage, without losing any operational efficiency. Whereas today you might get you might get that indication, and then you have a gap in coverage or a gap in solving the mission.
So, what advice would you like to give to veterans or technologists looking to lead in emerging tech sectors like AI and energy?
That question, like we need that kind of energy. We need that talent, that human talent. I would say jump in the game. Come in with the the skills that you learned in defense. The discipline, the reliability, the teamwork, and that tenacity, that ability to get through tough times. Bring that in, jump in, and start tackling these problems. Because there's and then use those teamwork skills. Because when you're in the military, you're working with people from all over the country, all different backgrounds, different perspectives on life. So you take that same kind of perspective and you work with scientists, you work with engineers, you work with you know, uh, technicians, right? You work with all these different people that have a completely different insight of the problem, and you can learn from them to, whatever problem you're tackling, you can learn to make it better because you have that kind of pollination of good ideas and best practices and insights you might not have come up with on your own.
And how to work as a team versus a team of one, right? Working collectively and hearing everyone's thoughts and ideas. So, as we start to wrap up here, who is, we got an audience watching this right now, probably across a lot of different companies and sectors. Who is the ideal customer that you're looking for?
Our ideal initial customers, again, we're rolling out the first versions of Energy Mind, are those customers that will gain the most out of an additional 20% range. And that have, so they operate, what you're looking at is, an autonomous system, whether it is a boat, a UAS, a drone. We're starting with these battery powered systems. So if you're operating out there and you are operating in variable environments where you have different weather conditions, different temperature profiles, and you have variable mission needs on your subsystems. You need to have sensors or communications devices or the propulsion. All those different things can be regulated across the mission. That's where that 20% is could be a lot higher depending on the variability of that mission. We kind of jump right in on those drone manufacturers that are have those variable environments. And that also extends to like expeditionary storage, energy storage systems, ESSs, and things like that, where you're operating in different environments where you have a variable draw on the system. Both those type of customers, both the stationary and the moving autonomous system are our early, that are battery powered. Those are our early customers that are going to gain the most from Primordis' technology.
Excellent. And so my last question here is where can people learn more about Primordis? And are you currently partnering or seeking collaboration partners, investors?
Yeah, we are actually in the middle of raising funds from investors. That's going fairly well, and we have some strong collaboration partners, but we certainly are looking for more. We have to be tactful in how many partners we take on, and as any young company does, because we could get overwhelmed by the number of customers. I see this technology as incredibly valuable to a lot of people and a lot of different industries. So we really are looking for those technology partners who are eager to work together, eager to solve problems together, and build this at a fast rate because we want to move fast.
Excellent. Marcus, thank you. It's been an honor. I am so excited to work with you all, and I look forward to seeing where this goes. So thank you so very much for your time today.
Likewise, William. Thank you.
You're welcome, sir.